Here we have a free fall problem where a pebble is dropped down a well that is 12 meters deep. How much time will it take for the pebble to reach the bottom? So we start by writing down our givens. Now I'm going to actually draw a picture to begin. And we have our well. And the pebble falls down this well, and it falls a distance of 12 meters. And we'll see why I draw a picture in a little bit. We write down our givens, and we are given that it falls 12 meters. So that is our delta y in this case. We're going to use the letter y instead of x because it is moving vertically instead of horizontally. It is 12 meters. Now, the picture lets me see that it is moved down, and downward is a negative direction. So we must put that delta y as a negative 12 meters. And that's why I drew the picture in the first place. We also have that it is dropped. Whenever you see a word dropped, we know that the initial velocity in this case is 0 meters per second. And moving through the air, we always know the acceleration while moving through the air is a negative, because it's down. The acceleration is negative 9.81 meters per second squared. So the difference with these problems in free fall is that we always know the acceleration. We need to find how much time, so we're looking for delta t in this problem. So we go to our equations, and we see that our equations are the exact same as before, only now we have y's instead of x's. We need to solve for time, so right away I see the fourth equation is out. That one's not going to work. Out of the other equations, here we have time. So we need to know acceleration, which we do, the initial velocity, but we don't know the final velocity, so that equation is not going to work. Our second equation, we're solving for time, so we need to know acceleration, which we do. The initial velocity is 0, and delta y is negative 12 meters. So that's the equation we're going to use. Let's rewrite this equation over to the side. We have delta y equals vi delta t plus 1/2 a delta t squared. So we put in place our values, negative 12 meters equals, well, anything times 0 here is going to be 0. So 0 times time is just 0, plus 1/2, the acceleration is negative 9.81 meters per second squared, times the time squared. Solving for the time, we get 1.56 seconds. Now, one thing that I do want to point out here is that if we would not have had the negative on our displacements, we would eventually be trying to take the square root of a negative number. That's an imaginary number. So if ever you come across trying to take the square root of a negative number, chances are you forgot a negative on your displacement. Usually that's where the negative is forgotten.